Hello, I'm Professor Von Schmohawk, and welcome to YU. In the last lecture, we saw how an equation for a line can be written in slope-intercept form. This form of a linear equation is written as y equals mx plus b, where x is typically chosen as the independent variable, y is the dependent variable, and m and b are constants. We saw that the constant b determines the point at which the line intersects the y-axis. This point is called the y-intercept, and its coordinates are 0, b. We also saw that the constant m determines the slope of the line. But what exactly is slope? The slope is a number which specifies how much a line is tilted from the horizontal position. The sign of the slope indicates which way the line is tilted. A positive slope indicates that the line's elevation increases as we move to the right. And a negative slope indicates that the elevation decreases moving to the right. The magnitude of the slope is determined by the amount of change in the line's elevation over one horizontal unit of distance. The greater the change in elevation over 1 unit distance, the greater the slope. This mathematical concept of slope corresponds to our experience in everyday life. A level road has a slope of 0. A road with a small slope changes elevation a small amount every kilometer. A road with a larger slope changes elevation by a larger amount in the same distance. Likewise, the slope of a line is defined as the number of units by which its elevation changes as we move 1 unit to the right. For example, if when moving 1 unit to the right, the line's elevation increases by 1 unit, then the slope of the line is 1. If the elevation increases by 2 units, the slope is 2. Likewise, if when moving 1 unit to the right, the elevation decreases by 2 units, the slope is negative 2. The elevation of a horizontal line doesn't change regardless of how we move, so its slope is 0. When calculating slope, the type of units used to measure distance does not matter, as long as we use the same units to measure both the horizontal and vertical distances. Using this definition for slope, we can determine the slope of a line by examining any 2 points on the line which are separated by a horizontal distance of 1 unit. Since the slope of a line is the same at every point, the 2 points we choose can be located anywhere along the line, as long as the points are separated horizontally by exactly 1 unit. The slope is simply the change in elevation as we move from the left point to the right point. Since the y-coordinate of a point represents its vertical position, the difference in elevation is the y-coordinate of the right point minus the y-coordinate of the left point. This difference in y-coordinates, as we move 1 unit to the right, is the line's slope. To see how this works, let's find the slope of the graph of the equation y equals x. We start by picking a pair of points on this line separated horizontally by 1 unit. For instance, we could pick the points 3, 3 and 4, 4. The right point of this pair has a y-coordinate of 4, and the left point a y-coordinate of 3. The elevation difference is the y-coordinate of the right point minus the y-coordinate of the left point, which gives us 4 minus 3, or 1. So the slope of this line is 1. Now let's find the slope of the line y equals negative x. Once again, we can pick any 2 points separated horizontally by 1 unit. If we pick the points 3, negative 3, and 4, negative 4, the right point's y-coordinate is negative 4, and the left point's y-coordinate is negative 3. So the right point's y-coordinate minus the left is -4 minus -3, which is the same as -4 plus 3, or -1. So the slope of this line is -1. So far, we have picked 2 points with a horizontal separation of 1 unit. But what if we want to calculate the slope using 2 points which are separated by some other distance? We know how to calculate the slope of a line using a pair of points 1 horizontal unit apart. Since these points have a vertical separation of 2 units, the slope of this line is 2. But let's say we want to use 2 points on the line separated by a horizontal distance of 2 units. Now the horizontal separation is doubled. But notice that the vertical distance is also doubled. The vertical distance is now 4 units. Likewise, if we use 2 points with a horizontal separation of 3 units, the vertical distance is tripled to 6 units. This is because each horizontal unit adds the same change in vertical distance. Let's call the vertical distance between the 2 points delta y. The symbol delta is often used to indicate difference. This is appropriate since delta y is the difference between the points' vertical positions. Likewise, we call the difference in horizontal position delta x. If delta x is 1 unit, we know that delta y is the slope of the line. As we change the distance between the pair of points, both delta x and delta y change by the same multiple. If we change delta x by a multiple of 2 or 3, delta y also changes by that multiple. In general, if delta x is multiplied by any constant c, delta y will change by the same constant multiple c. Now, let's divide delta y by delta x. Since delta y is equal to c times the slope, and delta x is equal to c, delta y divided by delta x is the same as c times the slope divided by c, or simply the slope. This equality tells us that for any 2 points on a line, the difference in the y-coordinates divided by the difference in the x-coordinates is the line's slope. This definition is simple but powerful. It is a definition which we will use many times in higher mathematics, as well as in other branches of science and engineering. If we know the coordinates of any 2 distinct points on a line, we can use delta y over delta x to calculate the line's slope. As an example, let's use this to calculate the slope for a line which runs through 2 points with coordinates 3, 3 and 7, 7. First, we calculate delta y and delta x. As we saw before, delta y is the y-coordinate of the right point minus the y-coordinate of the left point. So delta y is 7 minus 3, or 4. Likewise, delta x is also 7 minus 3, or 4. So the slope, delta y over delta x, is 4 divided by 4, or 1. As a second example, let's calculate the slope for a line which runs through the pair of points 3, -3 and 7, -7. Once again, delta y is the y-coordinate of the right point minus the y-coordinate of the left point. This time, delta y is -7 minus -3, or -4. And delta x is 7 minus 3, or 4. So the slope, delta y over delta x, is -4 divided by 4, or -1. When using this formula to calculate a line slope, no matter which 2 points on the line we choose, we will always get the same answer. As an example, let's try calculating the slope for a line using several different pairs of points. Let's say that we know of 3 points which fall on this line. The points with coordinates 8, 5, 4, 3, and -6, -2. We will start by calculating the slope using the points 8, 5, and 4, 3. Delta y is the y-coordinate of the right point minus the y-coordinate of the left point, which is 5 minus 3, or 2. And delta x is the x-coordinate of the right point minus the x-coordinate of the left point, which is 8 minus 4, or 4. So the slope delta y over delta x is 2 divided by 4, or 1/2. Now, let's calculate the slope of the same line using a different pair of points, 4, 3, and -6, -2. Once again, delta y is the y-coordinate of the right point minus the y-coordinate of the left point, or 3 minus -2, which is the same as 3 plus 2, or 5. And delta x is the x-coordinate of the right point minus the x-coordinate of the left point, or 4 minus -6, which is the same as 4 plus 6, or 10. So the slope delta y over delta x is 5 divided by 10, or 1/2, the same value we calculated before using a different pair of points. Now let's calculate the slope one more time using the points 8, 5 and -6, -2. Once again, delta y is the y-coordinate of the right point minus the y-coordinate of the left point, or 5 minus -2, which is equal to 7. Delta x is the x-coordinate of the right point minus the x-coordinate of the left point, or 8 minus -6, which is equal to 14. So the slope delta y over delta x is 7 divided by 14, or once again, 1/2. No matter which pair of points on this line we choose, the calculation for slope will always result in the same value. This makes sense since, as we saw, the equation for a line contains a single constant m, whose value is the slope of the line. Since there is only one value for a line's slope, a line must have the same slope everywhere, no matter which 2 points are used in the calculation. As a general example, let's call the left point point 1 and the right point point 2. We will refer to the coordinates of point 1 as x1 and y1, and the coordinates of point 2 as x2 and y2. Now, delta y and delta x are y2 minus y1 and x2 minus x1. So the slope delta y over delta x is y2 minus y1 over x2 minus x1. This is the general formula for the slope of a line given any 2 points on the line with coordinates x1, y1, and x2, y2. Of course, this can also be represented as delta y over delta x. Sometimes the difference in elevation, delta y, is referred to as the rise, and the difference in horizontal position, delta x, is referred to as the run. So an easy way to remember this formula is that the slope is equal to the rise over the run. In the next lecture, we will use this formula for slope to create a different form of the equation for a line called the point-slope form.